Hi, this is Todd with Land of Math. So you're trying to write a repeating decimal as a fraction. No problem, we got you covered here. In this video, we're going to walk you through all the steps to convert any repeating decimal into a fraction, and we'll give you a few examples. Also, there's actually one repeating decimal we can't write as a fraction, and we'll talk about that one at the very end. So all that's coming up next on the Land of Math.
All right, let's look at how we can write a repeating decimal as a fraction. So here's our first example. In this case, we have the 0.5, which is repeating. So what we're going to do is we're going to give this 0.5 repeating the value of x. So x equals 0.5 repeating. And what we're going to do next is just multiply both of these by 10. Now for the x, that just means it's going to become 10x. But for the 0.5, which repeats, it's going to turn into 5.5 repeating. So we multiply both sides by 10. Now what we're going to do is we're going to get rid of the 9, or get rid of one of the x's. So on the left side, it's going to be 9x. On the right side, what we're getting rid of is this 0.5 repeating. So when we get rid of an x, that's what we get rid of. So what's left on the left side is the 9x. And on the right side, what we're left with is just the whole number 5. So 9x equals 5. What we would do next, because we have a one-step equation here, we're just going to divide both sides by 9. On the left side, we're getting rid of the 9. We're left with x. On the right side, we already have a fraction. We have the fraction 5/9. So we'll just keep 5/9. So 0.5 repeating equals the fraction 5/9. So let's say we want to check our work just to see if this really makes sense. So what we can do is we could take, because all fractions are division problems, we can just take 5 divided by 9, and you can see that we're getting 0.5 repeating. Our second example, so this has the two digits repeating. So let's say we have a situation where we have 0.63 and it repeats. Just like before, we're going to say x equals the 0.63. We're going to multiply both sides by 100. So on the left side, we have 100x. And on the right side, we have 63 and then just repeating 63s. We're going to take away one of the x's from both sides. So from the left side, when we subtract 1x, that's just going to leave us with 99 x's. On the right side, though, this is kind of the key part. On the right side, we're going to be left with 66. We've eliminated the part that repeats, so it's gone. Now, just like before, we're going to divide both sides, in this case by 99. On the left side, the 99s will cross each other out, and we have x. And on the right side, we have 63 99ths. It's already a fraction. We can just keep it. Now, it will simplify. So if we divide both sides by 9, it will simplify to 7/11. So the repeating decimal of 0.63 can be written as a fraction 7/11. And again, if we check our work, if we take our 7, we divide it by 11, you can see here that we're getting 0.6363, and it just repeats on and on forever, which is what we got. Example 3. In this example, we have 3 digits that are repeating, in this case 1, 2, and 3. So just like before, we're going to assign it the value of x. So x equals 0.123 repeating. We're going to multiply both sides by 1,000. So we have 1,000x on the left side, and on the right side, 123.123 repeating. I'm taking away 1x from both sides. So on the left side, we're left with 999x. On the right side, I'm left with 123. Within, because those two cancel each other out. So now what we're going to do is divide by 999. On the left side, they just cancel out and we're left with x. On the right side, we have the fraction 123 999ths. Now it does simplify down to 41 over 333. So the fraction for 0.123 is 41 over 333. We'll check it, we'll divide it, and when we do that, you can see we're getting 0.123, 123, and so on. All right, in our fourth example, we have one digit repeats. It's not the number in the 10th spot, though. It's in the 100th. So in this 0.26, the 6 repeats. So we're going to make x equals 0.26 with 6 is repeating. we're going to multiply both sides by 10 and get 10x equals 2 point with the repeating 6's. So just like before, we're going to get rid of one of the x's on the left, and on the right side, we're going to get rid of the equivalent of the x, which is 0.2, and then repeating 6's. So the 6's on both of these are just going to go on forever, and they'll all cancel out, except for right over here. So when we do our next step, we have 9x on the left. When we take 2.6 and then we subtract the 0.2, we end up with 2.4. We want to isolate the variables, so we want to get rid of this 9. So I'm just going to take 9 divided by 9, which is going to be 1x or just x. On the right side, we have 2.4 divided by 9. We don't want a decimal in the numerator, so we're going to multiply both the top and the bottom by 10. So that's going to make it 24 over 90. So now we can simplify this fraction. 6 will actually divide into both of these numbers. So when I divide them, I end up with 4/15. So x equals 4/15. Now, if we want to check this, again, like I said, the 0.26 with the 6 repeating is going to equal to 4/15. So let's say we want to check this now. We'll just type in 4 divided by 15, and we get 0.2 with the repeating 6's, just like we started with. All right, this next example is very similar to the last one. We have 0.25 with our 5's repeating. We're going to make x equal to 0.25 with 5 repeating. We multiply both sides by 10. We get 10x equals 2.5, and then the 5's repeat. We're going to take away 1x on the left side, and on the right side, we're going to subtract the equivalent to that, which is 0.25 with the 5's repeating. After we subtract, we're going to end up with 9x on the left side. On the right side, we have 2.3. We're going to divide both sides by 9. So that's going to leave us x equals, and it's going to be the fraction 2.3 over 9. But we don't want a decimal in the numerator. So we're going to multiply both sides by 10 and kind of move that decimal over, and we end up with 23/90. So x equals 23 over 90. So we know that 0.25 as a fraction would be written 23/90. So let's find out if it's accurate. We'll take 23 divided by 90, and you can see we get 0.2 and the 5's repeat. On our next example, this is actually the exception to the rule, and it involves a repeating 0.9. So if we did what we've done before, we're going to say, okay, x equals 0.9 when it repeats. And we're going to multiply both sides by 10, and that's going to give us 10x on the left. And on the right side, we're going to have 9.9, and the 9's will repeat. The next step we would do is we would take away 1x from the 10x, and we would subtract the 0.9 repeating from the right side. That's going to leave us with 9x equals 9. So the repeating 9's cancel each other out. We divide both sides by 9, and that's going to give us x equals 1. So 0.9 repeating is equal to 1. So when you're looking at all these repeating 9's, and again, the 9's are just going to go on forever and ever and ever. And when you compare that to the whole number 1, and the 0, 0 is just going to go on forever and ever and ever, the gap is so small that basically we could just determine that point with repeating 9's is basically the exact same thing as 1, and so there's no difference. Well, hope the video was helpful. Hope you give it a thumbs up. We would love it if you'd subscribe to the channel. Until next time, we'll see you on Land of Math.